Okay, so today we're going to be when this loads. Okay, today we're going to be talking about systems of equations and solving system of equations. So yeah, but okay, we'll start off with the homework. So these are the answers to the homework. And I'll pull up the homework and just quickly go over how to answer these problems. But for those of you guys who did the homework and you want to compare your answers, you guys can compare it to this slide to check if you were right or if you're wrong. And I'll explain how to do each problem. So, yeah. But that's the answers to the homework, and I'll just pull up the problems here. So, okay, so here's a problem. The first problem is that if a recipe needs 4 cups of flour for 2 cakes, how much flour is needed for 5 cakes, right? And how I did this was that if it's 4 cups of flour for 2 cakes, right, that's a ratio of 4 to 2. It's also a ratio of 2 to 1, right? So then 1 cake needs 2 cups of flour. Then 5 cakes needs 5 times 2, which just equals 10 cups of flour. So I do the first problem. The second problem is a school has 300 students and the ratio of boys to girls is 5 to 7. So how many girls are there? Well, if the ratio of girls to boys is 5 to 7, then the ratio of girls to total is 5 to 7 plus 5, which equals 12. And then you can do 300 times 5 12, which should just get you 175. Yeah, that means there's a total of 175. For 3, a tank is filled with water at a rate of 12 liters per minute. So how long is it going to take to fill a 1,080 liter tank? Well, you can do 1,080 divided by 12, and that should just get you the answer of 90 minutes. And then for 4, a student mixes paint in a ratio of blue to red to yellow, which equals 2 to 3 to 5. And if she uses 40 milliliters of yellow, then how much total does she have? Well, we know that yellow is going to be yellow to total would just be 5. The ratio would just be 5 to 5 plus 3 plus 2, which equals 5 to 10, so 1/2. So yellow is 1/2 of the total. That should just get you the answer of 80 milliliters. Then for 5, a cyclist pedals at 18 kilometers per hour for 40 minutes. So how far does she travel? Well, one way I did this was I set hours to minutes. So then that's just 18 kilometers per 60 minutes, right? So then how far does she travel? Well, then you can just multiply the 40 there so that you can cross out the time. So then that's just 2/3 times 18, which should just be 10 kilometers, if I'm not mistaken. Yeah. Um, or sorry, no, that should be 12 kilometers. I did that wrong in my head. Um, okay. So then for pause. Okay, yeah. Pause. Yeah, okay. So then for 6, a factory produces 150 items for, yeah, 150 items in 5 hours. So how many items can it produce in 8 hours at the same rate? So then this is just 150 over 5 equals x over 8, and we can just find out that should just be 240 if you solve for x, because 150 over 5 is just 30. So then 30 times 8 is 240. Yeah. Wait, pause. Okay, yeah, no, 7 is still. Okay. So then for 7, it's 2 cyclists start together. One cycles at 20 kilometers per hour, the other at 15 kilometers per hour. So how far are they after 2 hours? So you can just multiply 2 hours to both, and that's just one is going to be at 40 kilometers, the other is going to be at 30 kilometers. So 40 minus 30 is 10 kilometers. And for 8, a student spends 2/5 of her money on books and 1/4 of the remainder on a pen. So if she had $100 initially, how much is left? Well, if she spends 2/3 of her money on books, then you have 3/5 of the money that's not spent, right? that is $60. And then 1/4 of the remainder on a pen, that means 3/4 isn't spent. And then 60 times 3/4 should just give you $45. So those are the answers to the homework. Does anyone have any questions about the homework? Like they didn't get an answer and they don't understand through my explanation. If so, you can put it in the chat. But I'll like wait a second, but if not, then yeah. Okay. I don't think anyone has said anything, so I'm just going to move on. For number 8, it's 45. I think that's what you're talking about, right? Yeah, number 8 should be 45 because if she spends, it's how much money is left. So if she spends 2/5 of her money on books, right? So she first spends 2/5 of her money on books. So then she'll like save like the how much she'll have left is going to be here. I'll just type that. So then she'll have 100 times 3/5, right? So that's how much she'll have. And then afterwards, she spends 1/4 again, like of that money on a pen. So then instead of multiplying by 1/4, we multiply by 3/4. Because 1 times 3/5 times 3/4. Because that's how much money that she has after the pen, right? And then if we just do this math, that just becomes 60 times 3/4, which equals 60 divided by 4 is 15 times 3. So that's just $45, not 25. You might have just done some arithmetic wrong because it's easy to mess up the math. But yeah, that's the explanation for that question. Okay. Other than that, does anyone have any questions? I'm open to answering, but yeah. Okay, that's good. Thanks for your question. I'm glad you were able to clear that up. But if no questions, um, then yeah, we'll move on. So today we're going to be talking about system of equations. So we're going to just go with definitions, right? So here are some of the basic foundation definitions. Like an equation is going to be just a statement with an equal sign. I think this is that part is review. Most of you guys know an equation is how to solve an equation. So just keep them in mind. And then system of equations is just when you have two or more equations with the same variables, but there's typically going to be multiple variables. So like a good example of this is like 2x plus y equals 4 and negative 3x plus 5y equals 7. So these combined are a system of equations. These two equations, right? Notice how there's two variables. We now have x and we have y. And there's two equations, right? So that's going to be a system of equations. And then the solutions to a system of equations is going to be finding values that work for all the equations. So today we're just going to be talking about using two equations. You can apply this to using like 3 equations and 3 variables, but we're only going to be working with 2 variables and 2 equations just because I can plot it like on a graph, like if you see this over here. So yeah, that's some basic definition. Okay. Okay, sorry, yeah, my computer's not loading, so. Okay, so next we're gonna go to types of solutions. So, there are 3 cases when you have 2 variable equations. So, for types of solutions, right? You can have one solution, so that's when the 2 lines intersect, right? So if we're going to put this on a coordinate plane with like y and x, then xy, the point, is going to be the solution. Or you could have no solution. So no solutions is when the lines are parallel. So they'll never intersect, right? Like they'll never touch each other. There's no point that is on both of the lines. Or you could have infinite solutions. Infinite solutions is this funny case because that's when the two lines are actually the exact same line, right? The equations are the same. Um, so then that's when you have infinite solutions because all the points on one line are on the other line as well. And as you define, a solution is a point that's on both of the lines. So, yeah. So if we look over here, right, we can see that this graph, these two lines, which is the example, there's one solution because they intersect at one point over here. And after this, they never intersect. So that's an example of one solution. So yeah. So then here are just like some examples of each solution. When we put them in equation form, we're not going to be doing much graphing here. It's mostly just going to be like equation stuff. So should be good to know. So an example of like one solution is if you have like y equals 2x plus 1 and y equals negative x plus 4. I don't need to solve for the solution yet because one, I haven't taught you that. I'll teach you that in a bit. But when you write it in this form, right, like y equals something x plus 1, that's like the slope-intercept form, right? You can see that they're like the x coefficients when they're simplified, so there's no common factor here, right? And the slopes are different. We have 2 and negative 1. And if you look on a graph, like if you plot the points, you can see that they're different lines and they're not parallel. And since the slopes are different, that means that they're going to intersect. And just make sure that your y coefficient is 1 when you do this, or you factor out all common factors, because if you don't do that, then sometimes like it can get confusing. So an example of no solution is this one, right? Y equals 2x plus 1 and y equals 2x minus 3. So we can see again, the coefficients are simplified. There's no like common factors involved. And their slopes are the exact same, right? But their y-intercepts are different. And since their y-intercepts are different, that would mean that they never intersect. And I'll like graph this because that'll probably make it easiest for you guys to look at. But if you have like y equals 2x plus 3, or no, plus 1, and then y equals 2x plus 2x minus 3. See, these lines are parallel. They never intersect. So there's no point that will lie on both of these lines. That's just not possible. Or you could have y equals 3x plus 2 and 6x minus 2y equals negative 4, right? So when we first look at this, well, we see that the x coefficient, there's a 6 and there's a 3. So these look kind of different, but let's take kind of a closer look. When we look at the second equation, right, and we look at the coefficients and constants, we have 6, negative 2, and negative 4. These are all even numbers, so we can factor out a 2, right? If we divide both sides by 2, then you get 3x minus y equals negative 2, right? And then now we isolate the y, so then we get y equals 3x plus 2. But that's the same exact line as the first equation, right? So these two equations are the exact same, so every point on one line is also on the other line, so there is infinite solutions. Does anyone have any questions about all of this stuff? Or does this make sense? And yeah, don't be afraid to ask questions. But that's types of solutions. We're just going to be dealing with these 3 types. Okay, I assume we're good. You can always ask if you have questions. So we'll have practice problems now. So for these problems, I give you 5 sets of 2 equations. So I want you guys to identify the number of solutions, right? If it's one solution, no solution, or infinite solutions. I don't like if it's one solution, right? I don't need to know what the solution is. I just want to know if there is a solution or not, or if there's infinite solution. So I'll give you guys time to work on these problems, and once you guys finish, you can message me something, or if you want to explain a problem, you can raise your hand or message me what problem you want to explain. And for the problems that like no one wants to explain, I can explain them. But yeah, this is like a practice for us to test your knowledge. And yeah, let me know if you have any questions about these problems or anything. Alright, I'll give you guys, like, 1 more minute. Yeah, Darlena, do you have a question? Sorry, I don't think I saw that hand.
I want to answer the problems.
Okay, which one?
Number 1.
Okay, um, before you do that, I'm glad you wanna answer, but before you do that, does anyone need more time to do these problems? Okay. Carmela, how many minutes do you think you need approximately? Okay, 1 or 2 minutes? Yeah, I'll give you, like, maybe a minute. We'll go up to, like, 8:25, and even if you don't finish, that's totally okay. I just want you guys to, like, grasp how to do these problems. So between 8:25 and 8:26, I'll stop us, and yeah, but no pressure to do it fast. Like, take your time. I'd rather you, like, get it right and understand. These problems are just there so that, we can do a little bit of practice, but I'll get back to you guys in maybe, like, 30 seconds, and then we can talk about the problems. Okay, I think we're gonna start explaining the problem now. Darlena, do you wanna answer problem 1?
On problem 1, I got just one unlimited um because first I simplified the second equation, which I got 3x plus 2y equals 7. So I found that they were the same. So if they're the same equation, it's unlimited.
Perfect. Okay. Yeah. So the first one is infinite because we can factor out at 2, just like Darlena said. So good job. You can factor out at 2, so 6 becomes 3 and 4 becomes 2, and then 14 just becomes 7. And that's the exact same equation as the first one. So yeah, that one has infinite. And then for problem 2, we can see that it's 2x plus y equals 6, right? And then 4x plus 2y equals 12. Just like in the first equation, we can see that we can also factor out the 2 here, right? Because there's a common factor of 2. So then you get 2x plus y equals 6. And yeah, you can answer 5. I'll just go in order, and then once we get to 5, we can answer. Perfect. So then once we get there, then you see that's just 2x plus y equals 6. And that's the same thing as the first equation. So again, that's infinite or unlimited solution. Then for problem 3, we have y equals 4x plus 1 and y equals negative 1 plus x plus 1. Well, if we look here, we can see that their coefficients are different, right? 4 and negative 1/4 are not the same. And the y coefficient is also the same. So we can instantly know that there is only one solution to this one. And then finally for problem 4, we can see that it's y negative 3x plus 5 and y equals 3x. Y plus 3x equals negative 7. And then if we move the 3x to the other side for the second equation, then you get y equals negative 3x minus y equals negative 3x minus 7. And if you look at that, well, both of these equations have coefficient negative 3, right? But their y-intercepts are different. One of them is 5, and one of them is negative 7. Oops, sorry. So that would mean that there is going to be no solution because their slope is the same, but the y-intercept is different. And then Zoe, do you want to do number 5?
Five. For my first step, I did the first part, which is y equals 2x plus 3. And if you look at the second problem, y plus x equals 1, I looked at it like this. So plus 3 and like the answer, like the last number is plus 3 and then equals 1. So to get from 2x plus 3 to 1, I did 2x. X is -1, so that was -2 for 2x, and then y equals 1 because -2 plus 3 is 1. So y plus y plus x is 1. I think I did make a mistake there.
It's okay. We don't need the exact number, but do you want to share how many solutions there are? Like one solution, no solution, or infinite solutions?
There is one solution.
Good. Okay, perfect. Yeah. So it's okay that if we don't need to know the exact point, because I'll explain that like next. So that's totally fine. But we just need to know if there's one solution, infinite solutions, or no solution. And we can tell because if we move the x over, then for the second equation, we get y equals -x plus 1, right? So then their coefficients are different. So their slopes are different. So that would mean that there is going to be only one solution. So that's all we need to know for this question. Finding the point, we're going to learn this next. So it's okay. But Zoe was on the right track actually for doing that. I think it was just a little like arithmetic. It's okay. Okay, so these are just the answers. Infinite, infinite, one solution, no solution, and one solution. Yeah. So yeah, I'll move on to the next part. So the next part we have the methods for solving the system of equations, right? So the first method I'm going to talk about is the substitution method, and the second method I'm going to talk about is the elimination method. So if we're given two equations with two numbers, or a system of equations or with two variables, how do we find the answer? So one method is what I call substitution. And substitution is basically when you find the answers by solving one equation for one variable, then finding the second variable. And that probably does not make much sense. But I'll show you an example of it, so hopefully that will make more sense. But like an example is this, you have these two equations, right? -2x plus y equals 3 and x plus y equals 9. So one way that we can do this is that we can see that for the first equation, right, we get y equals 2x plus 3 if we move the 2x around, right? So then we can replace this y in the second equation, right? Because this point should satisfy both equations. So then we can see, oh, look, it's y. So then x plus y can just become x plus 2x plus 3 equals 9, right? So then 3x plus 9 minus 3. 3x equals 3x equals 9 minus 3, which equals 6, and then you can see that x equals 2, and that just means that y equals 2 times 2 plus 3, which equals 7. So that's how you get the answer x, y is equal to 2, 7. And you can double check this, right? Like we can plug it into both equations to see if this works. And we can see that for the first equation, right, -2 times 2 plus 7 does indeed equal 3, right? Because that's just 7 minus 4 equals 3. And then for the second equation, x plus y is 2 plus 7, which equals 9. So this works. So basically substitution is when you solve for one number in terms of the other number, right? So in this case, we solve for y in terms of x, right? We want to represent y with the term x, right? So we wrote y as y equals 2x plus 3. And then we plug that 2x plus 3 into the second equation to find what x was. And then using what x was, we could find what y is. So that's the substitution method. And feel free to stop me if you have any questions or if something doesn't make sense. But that's just the basics for substitution. I just want to say that, you know, this worked out very well because we had like the y over here, so we could just solve it. You could also do this for x, where you could have x equals 9 minus y, and then just plug that in over here, find what y is first. You're gonna get the same answer regardless, but it made it a little easier to look for y because there's just like one y over here versus having an a coefficient over here. And you can still do substitutions if there's a coefficient in front of the number. You just have to multiply it out, which sometimes can be a little harder. Sometimes not, just depends on what you're comfortable with. And also, given these two methods, there's never one right way. You can answer it both ways and you're gonna get the same answer, but sometimes it like just might be easier to do it one way. But that's the substitution method. And yeah, feel free to ask questions. Anyone have any questions? But the second method is called the elimination method. And elimination is basically when you add or subtract these two different equations, right? To cancel a variable so that you can solve for the other variable. So we'll start off with an example, right? We have 2x plus y equals 10 and 6x minus 2y equals 10, right? Well, there are multiple ways to do this, but I think that, you can obviously use substitution because we see a y there, right? We can say y equals negative 2x plus 10. But there's another way to do this. We can see there's a plus y and there's a negative 2y, right? So if we want to cancel, we want to get a plus 2y, right? Because then we just want the equation in terms of x. So what we'll do is we'll multiply both sides of the first equation by 2. Because if you multiply one side, you have to multiply the other side, because that's called an equation, because they're equal. So then you get from 2x plus y, you'll get equals 10, you'll get 4x plus 2y equals 20. And then you can add these two equations. We can add the left side of both equations, so we can add 4x plus 2y, and we can add that to 6x minus 2y, right? And then that's just equal to 20 plus 10, right? Because then these are the right side that we're adding. And then we can see that the 2y and minus 2y cancel out, right? So then that's when you get 10x plus 0, because those two cancel out, equals 30, right? So then x equals 3. And then 2 times x plus y equals 10, right, from this first equation. And if we plug x equals 3 in, then we get y equals 6 plus y equals 10, so y equals 4, and your answer is just going to be 3, 4. And we can just plug this in to double check, because we should always double check when we do this to make sure if we did anything wrong, right? If we put back into the original equations, we're going to get 2 times 3 plus 4, which equals 6 plus 4, does equal 10, correct. If we put in the second equation, then we get 6 times 3 equals 18, minus 2 times 4, which is minus 8, 18 minus 8 equals 10. Okay, does anyone have any questions about the elimination or substitution methods? Does anyone not understand anything? Because it can be a little bit confusing at first. Okay, if anyone has any questions that come up, feel free to message me. But now I'm just gonna quickly compare the methods, right? So generally, obviously, like I said, feel free to choose whatever method works for you, right? Like I think when I was younger, I like to use the substitution method more than I like using the elimination method. That was just me. And I could use that for every single question and I could still get the right answer. But sometimes the answers would be a little bit harder to get, and like they weren't the numbers, it was like a little bit harder to use one method. So sometimes it's obvious which one to use, sometimes not. If you have like coefficients and constants are like small integers, or they're like factors of each other, right? Like if you have the coefficient of y is like 2 for one of them, and the coefficient of y for the second equation is like 6, then elimination is a pretty good method to use, right? It's easy to just get rid of one variable and then solve for the other variable. So normally when the coefficients and constants are small integers, so multiplication isn't too hard, it's good to use elimination. And when one variable is like already isolated, like if you have like 2x plus y equals something, and then you have like 3x plus 5y equals something else. Well, we see that the y is already isolated in the first equation, so it's very easy to just use substitution because we can find out what y equals very easy. Again, none of these are like resolute. Like you don't have to use substitution for those problems. You don't have to use elimination for small constants and coefficients. It's up to you, whichever you think is easier. There's no one fit all solution. Both of these methods work. Some might just take longer than others, and that's perfectly fine. And then sometimes like it's going to be neither of these options, right? You're going to have really big coefficients and constants, or you're not going to have an isolated variable. Then it's going to be hard to choose, and at that point, you just choose whatever you think is best for you. So yeah, I think that's all I really have on the comparing methods. So then today's class is not going to be super long. Yeah, we're just going to do like 3 more practice problems. The last one is a word problem, and these word problems are going to be relatively, I think they're actually pretty frequent in competition math. So if you guys are looking to like, after this course, if you're looking at like math counts or something, this is something that does show up sometimes. So, these should be problems to do. But again, just message me when you have your answer and what your answer is. And then we'll go over the problem. If anyone wants to explain, you can just raise your hand, tell me, or message me in chat. And yeah, I'll give you guys time to do this problem. Yeah, Darlena, do you have a problem that you want to explain, or do you have a question?
A problem that I want to explain.
Which problem do you want to explain?
Number 1.
Okay, yeah. I'll wait for people to I'll give them a little bit more time, maybe like 1 or 2 minutes to finish some of the other problems, and then we can go to explaining. So yeah, at I think 8:48-ish, we'll start explaining problems. So no rush. Okay, I think we're gonna start explaining problems now. If you haven't finished, that's totally fine. We'll just go over them. So Darlene, do you want to explain problem
I got 6 by I got 6 for the equations by putting the first equation in the second equation. Then I got x x x2, that x equal 2, and then I put it the x equal 2, and then I put it 2 in equation 1 to substitute for x, and then I added them together to get 6.
Okay, perfect. Yeah. So the answer, like Darlena just said, was 2, x equals 2 and y equals 6. So yeah, very good job. She used substitution to do this one. So we put 2x plus 4. So that's just 2x plus y. To get 3x plus 4 equals 10. So that would mean that 3x equals 6, x equals 2. You can plug that back into the first equation to get 2 plus 4, so y equals 6. You could also do this through elimination, actually, where you have y minus x equals 4, right? So then, yeah, so then you can just do you could times 2 to the side to get, or sorry, yeah, then you could just subtract it. So then you get 3x equals 6, and then you get x equals 2 again. Plug it back in, y equals 6. Does anyone want to explain problem 2 or problem 3? If not, that's okay. I can just explain it. Because we have time. Okay. So I will explain it. So for problem 2, how I did this was I did it by doing, if we look at the first equation, right? I'm just going to annotate because it's easier. We can see that there's a common factor of 2. So if we divide both sides by 2, I get 2. x plus y equals 7, right? So that gets rid of the common factors. And now we can see an isolated variable, so I can use substitution, but I just want to show elimination, so I'll do this through elimination. So there's a 6x over here, and there's a 2x over here, right? So 6 equals 3 times 2. So I can just do 6x plus 3y equals 21, right? If we multiply both sides by 2. So then we can get 6x plus 5y minus 6x plus 3y, and then we can take 23 minus 21, right? So then in this case, I just get 2y equals 2, so y equals 1. Yeah, that should be right. Yeah, it is. And then if we plug that into the original equation, you get 4x plus 2 times 1, 14. Then 4x equals 12, and then x equals 3. So you should have gotten x equals 3 and y equals 1 for the second problem. Or, yeah. Okay. Now for the third problem, this one's like a word problem, but I'll just write it out on how you should do it. So I said t equals the price of tickets, right? And then p equals price of popcorn. For word problems, I like to just label the variables whatever the first letter of the word is, just because it's easier for me to remember, right? So 2t plus 1 popcorn equals 20, right? And then 1 ticket plus 2 popcorns equals 18. So then we're trying to see how much does 1 movie ticket cost? How much does 1 popcorn cost? Well, the easiest way for me to do it is, well, if I want to get rid of popcorn, right, then I can do 2 times, for the first equation, right, I might want to cancel out if I want to find out how much the movie ticket costs, right, I can just cancel out the popcorn. So then I can just do p plus p, which equals 4t plus 2p equals 40, right? And then t plus 2p 18. So then in this case, we could do 4t plus 2p and then minus t plus 2p, which is the second equation, equals 40 minus 18, right? That's this area minus this, the second area, which equals 40 minus 18. So then from here, we can get 3t equals 22. So t equals 22 over 3. So that's the price of a movie ticket. Now we can plug that in. 22 over 3 plus 2p equals 18. And then if we solve for p, which I'm not going to do the math, because you can use a calculator for that, you'll get that equals 16 over 3. So yeah, and if you put it into a calculator and you want like a number answer, that's just $7.03 or 33 cents, and that's just $5.33. So that's how we do the bottom question. It's system equations, just word problem version. So yeah, the answers are on this page. And for all of these problems, we can always plug the answer back in to check if we actually did it right or not. But if you plug it back in, the equation should. Okay, so finally, we're basically done. It's just a summary of what we did. So let's review. A system of equations is basically 2 or more equations with the same variables. And solutions can be 1 point, or like 1 solution, or you can have no solutions, or infinitely many solutions. And then substitution method is when you solve for one equation for a variable and you substitute into the other one. Elimination method is add or subtract equations to eliminate a variable. And then both methods will always end with the same answer, and you can always double check your answers by plugging them back in. And yeah, that's all we have. Again, if you have any questions, feel free to let me know. But that's all for today. So yeah, thank you guys.